Bismillahirrahmanirrahim. My dear students, here is your mathematics teacher Muhammad Saeed from Pakistan International School, Paris, Saudi Arabia. Today we will continue our lecture number 45, exercise 3.5 and first year class. Today we will have our question number 2 and the parts are given to us which are according to reduced syllabus. We have question number 2 and part number 2 and 3. Part number 2 and 3 are given here. So the question is, use matrices to solve the following system of equation. We can take part number 3. We have part number 3. Yes, in case of part number 3, we are given x plus y is equal to 2, x plus y is equal to 2, y is equal to 2, and 2x minus z is equal to 1, 2x minus z is equal to 1, and 2y minus 3z is equal to minus 1. 2y minus 3z is equal to minus 1. 2y minus 3z is equal to minus 1. First of all, you can check. That here z is missing. First of all, we will write down the terms with the missing variables as coefficient 0 coefficient. 0 z is equal to 2. In second, y was missing. 2x plus 0y minus z is equal to 1. Third is x is missing. 0x plus 2y minus 3z is equal to minus 1. Convert this into the matrix form 1, 1 and 0, 2, 0 and minus 1, 0, 2 and minus 3. Here we have x, y and z, and column matrix of constant is 2, 1 and minus 1. Name them as Ax is equal to B. This is using matrix method. Actually, we have to find the adjoint inverse of the matrix. So x is equal to B over A implies that x is equal to A inverse B. You will not write down B A inverse. Remember that B A inverse will not be simplified. You cannot solve that. This is A inverse B. This is equation number 1. So first of all, we will find a determinant, whether it is solvable or not. 1, 1, 0, 2, 0 and minus 1, 0, 2 and minus 3. Okay. Remove this row and column AD minus BC, 0 plus 2. Then minus 1 into minus 6 plus 0 plus 0 into 4 minus 0. 1 into 2 plus 6 plus 0. That will be 8. Not equal to 0. Solution set is possible. Actually, inverse is possible also. So we have determinant of A is determinant of A is 8 and definitely we will find the matrix of cofactors. Here we will find matrix of cofactors. The transpose of matrix of cofactor is adjoint A. This is the formula. This is the formula which will be applied here. A inverse is equal to adjoint A over A determinant. And adjoint A is transpose of matrix of cofactors. So A inverse will be found and then we will put here to find the value of x, y, z. Here we can have yes, A is 1, 1 and 0, 2, 0 and minus 1, 0, 2 and minus 3. Matrix of cofactors. Remember that I told you there is a very shortcut method. You can apply it. This is plus, minus, plus, minus, plus, minus, plus, minus and plus. First is matrix of cofactors. We have to write down a capital A. So cofactor of 1. What is cofactor of 1? This is 1. Cofactor of 1, outside this is a positive sign, AD minus BC. AD minus BC. It will make confusion. AD minus BC. Remove this row and column, that is known as minor of the matrix. So here is 0 plus 2, that will be 2. Cofactor of again 1, that is minus, remove this column and row, AD minus BC. Minus 6 minus 0. And minus minus plus, that is 6. Cofactor of 0 plus, remove this column and row, AD minus BC. 4 minus 0, that is 4. Then cofactor of this 2. Here is plus minus plus minus. Then remove this row and column, AD minus BC. Minus 3 minus 0, that will be 3. Then cofactor of 0 plus this 0. Remove this column and row, AD minus BC. Minus 3 minus 0, that will be minus 3. Then cofactor of minus 1, this minus 1. Remove this row and column, AD minus BC. 2 minus 0. This is minus outside, that is minus. Plus minus plus minus plus minus. And again cofactor of 0. Plus, remove this row and column, AD minus BC. Minus 1 minus 0, that is minus 1. Cofactor of 2, minus into, remove this column and row, AD minus BC. Minus 1 minus 0, that is plus 1. Then cofactor of minus 3, that is plus, remove this column and row, AD minus BC. 0 minus 2. Here is minus 2. Dear students, we have matrix of cofactors. Matrix of cofactor is 2, 6 and 4. Then 3 minus 3 and minus 2. Then minus 1, 1 and minus 2. Definitely this is matrix of cofactor, but you will take transpose of matrix of cofactor, which is actually adjoint A. Therefore, adjoint A is equal to transpose of matrix of cofactors. Remember that first row becomes first column, 2, 6, 4. Second row becomes second column, 3 minus 3 minus 2. Third row becomes third column, minus 1, 1, minus 2. Okay, then A inverse is equal to adjoint A over A determinant. We have adjoint A, 2, 3 minus 1, 6 minus 3, 1, 4 minus 2 minus 2 over A determinant was 8. Yes, A determinant is 8. Dear students, now we can apply the formula. We can apply the values. In equation number 1 to find the values of x, y, and z. It was x is equal to A inverse B using values. It was x, y, and z. A inverse is 2, 3 minus 1, 6 minus 3, 1, 4 minus 2 minus 2 divided by 8 into B. Into B. What was B? 2, 1 minus 1. 2, 1 minus 1. Remember that we can write down first into first plus second into second plus third into third. First row, this column. First into first plus second into second plus third into third. 2 2s the 4 plus 3 1 the 3 minus 1 is plus 1. Then second row column 6 2s the 12 minus 3 minus 1. Then third row and this column 8 minus 2 plus 2. And we are left with 8, 8 and 8 whole divided by 8. 8, 8 and 8. So every number is divided by 8 like that, and we are left with 1, 1, 1. So remember that x is equal to 1, y is equal to 1, and z is equal to 1. That is your answer. I hope that you understood this question. That was your question number 2. Exactly in the same way, I hope that you can solve this question with the same method by part number 2. After that, question number 3. Solve the following system by reducing their augmented matrices to echelon form and reduced echelon form. Remember that echelon form means this diagonal will be 1, 1 and below 0. All zeros. And if above zeros all, then it will be reduced echelon form. You can check this one is 1, 0, 0, 0, 1, 0, 0, 0, 1. If diagonal is 1, 1 above and below are 0, then this is known as reduced echelon form. If below 0, above non-zero, this is echelon form. So in this way, we can solve our next question. Question number 3. We have to solve augmented matrices. Yes. Question number 3. Solve the following system by reducing their augmented matrices. Question number 3. Number 1 is x1 minus 2x2 minus 2x3 is equal to minus 1. 2x1 plus 3x2 plus x3 is equal to 1. 5x1 minus 4x2 minus 3x3 is equal to 1. Dear students, you must understand, augmented matrices mean matrix of coefficient along with the constant right hand side column matrix of constants. That is known as augmented matrix. Augmented matrix is, this will be, remember that augmented matrix is, you will write down matrix of coefficients 1, minus 2, minus 2, 2, 3, 1, 5, minus 4, minus 3. This is the margin line, and right hand side you will write down column here, column matrix of constants, minus 1, 1 and 1. Column matrix of constant that will be written on margin line on right hand side of the margin line, this way. You will apply row operation first of all. This is 1, you have to make zeros down. I told you that diagonal will be 1, 1, 1 and below is 0, all zeros, that is echelon form. And if above and below all zeros, that will be reduced echelon form. So here is R2 plus minus 2 R1. If we multiply R1 by minus 2 and add here, it will become 0. And R3 plus, that is minus 5 into R1. Remember that 1, minus 2, and minus 1. This is multiplied by minus 2 added here, this is 0. Here is multiplied by minus 2 become 4 and added here, that will become 7. This is multiplied by minus 2, it becomes plus 4, added here, it will become 5. This is multiplied by minus 2, that will be plus 2 and added here, this will become 3. Then, this is multiplied by minus 5 and added here, this will be 0. Multiplied by minus 5 here, so minus minus plus 10 and 10 plus minus 4 is 6. This is multiplied by minus 5, 10 and 10 minus 3 is 7. This is multiplied by minus 5, that will become plus 5, then added here, it will become 6. Remember that here is 7. You have to make one here, dividing R2 by 7. So we are left with 0, 1, 5 over 7, 3 over 7. And here is 1, minus 2, minus 2, minus 1. 0, 6, 7 and 6. Remember that now you have 1 here. You have to make 0 down. How would you do that? Multiply R2 by minus 6 and add here. Minus 6 and add here. And that will be, where have we done that? This is multiplied by, this is, here was 1, we wanted to make 0 here. Minus 2 multiplied by here, this is 0, minus 2, then 4 plus 3 is, yes, 4 plus 3, actually the number 5 minus 4 minus 3, 5, 4 and 8, no, this is what we did that, question number, it was question number 3, 5 minus 4 minus 3, and 2, 3, 1, 1 minus 2 minus 2. Yes, we have written correct. Multiply by minus 2 here and add here 0. Minus 2 become 4 plus 3 is 7. Multiply minus 2 become 4. 4 plus 1 is 5. Multiply minus 2, that will be 2 plus 1 is 3. And here is, this is multiplied by minus 5 and added here 0. Minus 5, 10 minus 4 is 6. Then 10 minus 3 is 7. And this will be 6. 5 plus 1 is 6. Okay. So here we have 1. You have to make this 0. Below 0 here. For reduced echelon form, you have to make 0. So R3 plus minus 6 into R2. Minus 6 into R2. So we are left with 1 minus 2 minus 2 minus 1 0 1 5 over 7 and 3 over 7. This is 0. This multiplied by 6 and added here, it will become 0. This is multiplied by 6 and added here. Now minus 6 and added here. So it will be 7 minus 30 over 7. This is multiplied by minus 6 and added here. So minus 30 over 7 plus 49 minus 30 over 7, it will be 19 over 7. And this is again multiplied by minus 6. So we have 6 minus 18 over 7. It will be 6 minus 18 because multiplied by minus 6. Minus 18 over 7. 42 minus 18 over 7. That will be 4, 2 over 7. That will be 24 over 7. Here you have to make 1. That was 19 over 7. Here you will multiply throughout by 7 over 19. Multiply this number by 7 over 19 to make 1 here. Yes. Multiplying R3 by 7 over 19. 1 minus 2 minus 2 minus 1 0 1 5 over 7 3 over 7 0 0 and 1 7 over 19. 7 over 19. So 24 over 19. 24 over 19. So we can have, here is, remember that this is echelon form. From this echelon form you can have, this is 1x1 minus 2x2 minus 2x3 is equal to minus 1. Convert them again into the equation form. This will be x2 plus 5 over 7 x3 is equal to 3 over 7. Then here is 0x1, 0x2, then x3 is equal to 24 over 19. So we will apply x3 here in this second equation, we will find x2. We will apply x2 and x3 here, we will find x1. This is echelon form. Echelon form. So we can apply these values here. Yes, x3 is equal to 24 over 19. This may be taken as equation 1, this is 2 and this is 3. Using equation 3 and equation 2, using x3 in equation number 2. What is equation 2? x2 plus 5 over 7 into 24 over 19 is equal to 3 over 7. Yes, it will be solved. 7 over, after simplification, we can get x2 is equal to, dear students, we can check your answer. And here we will have 7 over 6. You can find the value of, by taking these number on the other side, then using value of x2 in equation number 1 and x2 and x3 in equation number 1, you can find your value of x1. In this way, dear students, this is known as echelon form. Remember that we will complete this question by the other method, which is more complete, easy for you people, because we have to make above these numbers 0 and 0 here, and that one will be the identity matrix. In fact, it will be x1, then x2, then x3. Directly you will find your answer. I hope that you can complete your next part, and we will do it inshallah in the next lecture. Okay, Allah Hafiz and Assalamu alaikum wa rahmatullahi wa barakatuh.